Now, some things that we will probably use in lab: percent difference. So if we make two measurements and we want to check them, see how close they are, we can do by percent difference. So the difference is one value subtracting the other value. That's the difference. Then we're going to divide the difference by the average. So it's going to be difference divided by average, and then times 100%. We usually do this as an absolute value, so we don't worry about the sign changing depending on which value we pick for x1 and which one we pick for x2. So percent difference is difference divided by average times 100%. And another thing that we will be doing in lab is percent error. This is comparing our measured value to an accepted value. So in this case, we're going to do the difference between our experimental value and the accepted value. Then we're going to divide by the accepted value. So it's the difference divided by accepted value times 100%. And again, we often do this as an absolute value. So just some comments on units when we do our calculations. When we multiply or divide, we are multiplying or dividing the units. So we want to keep an eye on this. When we have a unit divided by itself, like kilograms divided by kilograms, that becomes 1, which disappears from the unit list. So when we have a unit divided by itself, it disappears, it cancels itself out. When we add or subtract, we're not allowed to do this until we have made the units match. After the units match, then we can add or subtract. So we can only add or subtract when the units are matching first. So if we want to add 5 grams with 0.025 kilograms, units are not matching. We have to match them first, convert the kilograms into grams. Then we have 5 grams plus 25 grams gives us 30 grams. And for multiplication and division, if we have 4.0 grams divided by 0.25 moles, run 4 divided by 0.25 in our calculator, we get 16. We check significant digits. We have 2 in the 4.0, we have 2 in the 0.25. So 16 is correct with 2 significant digits. But we had grams divided by moles. They can't cancel out. So what we're going to do is just combine them together and show what the operation we did to them. So we end up with a gram per mole. Gram divided by mole, gram per mole. And we want to be able to convert between various units, and this can even be between physical properties. So what we're going to do is look at the units that we have and all the numbers that we have. We need to know the units of what we're looking for. And then we find ways of combining the numbers we have or pulling in other relationships, equalities, to be able to convert what we have to start with into the units of the answer. If we can do that, if we get the units of the answer, then the math should give us the correct answer. If we need something that relates to properties such as grams and kilograms, we find that relationship. So 1,000 grams equals 1 kilogram. By dividing one side into the other, we can get 2 types of unit factors out of this. 1 equals a kilogram divided by 1,000 grams, or 1 equals 1,000 grams divided by a kilogram. As a unit equation equal to 1, we're able to multiply anything by 1 and it won't change its value. In this case, it might change its number as it changes its unit, but the value will remain the same. And this is why I said, so any number can be changed, multiplied by 1, and it won't change its value. an equation can be multiplied by 1 without changing the value. An equation, an equality, can be multiplied by anything as long as we're multiplying both sides simultaneously, and it will remain an equality. So if we want to convert 2,745 grams to kilograms, well, we have grams, we want kilograms, so we need a relationship between them. Well, this is the 1,000 grams equals 1 kilograms. Well, we have grams, we want to get rid of grams. So to get rid of grams, we need grams in the denominator. So we turn our unit factor, our equation, into a unit factor by dividing by 1,000 grams. We get 1 equals a kilogram over 1,000 grams. Now when we multiply our 2,745 grams by 1 kilogram over 1,000 grams, we'll end up with kilogram times grams divided by grams. So the grams divided by grams will cancel out, leaving us with just kilograms. So we run it through our calculator, we end up with 2.745 kilograms. We're not going to change the number of significant digits, since the 1,000 grams equals 1 kilogram is a defined quantity and does not have any restriction on significant digits. So another example, if we want to convert 213.245 pounds to kilograms, we go and look for a conversion factor between kilograms and pounds. Where we get a kilogram is 2.205 pounds. And if we do this conversion, we're going to put our kilograms on top, pounds on bottom, so we end up with pounds divided by pounds, cancel them off. We end up with 96.70975 kilograms. But we check the significant digits. 213.245 pounds is 6 significant digits. 2.205 pounds is 4. That's not a defined quantity, so that will limit our answer to 4. 96.71 kilograms. If we really want to keep that 6, we go and look up a better conversion factor between our pounds and our kilograms. We end up finding one at 2.20462 pounds equals 1 kilogram. That will give us our 6 significant digits, and now we can get our answer at 96.7264 kilograms. 6 significant digits. We may need a couple different unit values. We might need a sequential operation here to make a calculation or conversion. So in this one, if we're recommended to drink a quart of water every 2 miles while we're hiking in Death Valley, so if we want to walk 26 kilometers and we have 500 milliliter bottles, how many bottles do we need to carry? Well, we got a bit to do on this one. We were given that we have a quart per 2 miles, what we're supposed to consume. We have 26 kilometers, and we have a bottle is 500 milliliters. So the first number is the rate, second number is distance. So if we multiply them together, they'll give us the total volume. And then the third number, we can convert our volume into total number of bottles. But our units don't match between the rate and the distance, so we're going to have to start correcting the units. So we add in our conversion between miles and kilometers. A mile is 1.609 kilometers. What we want to do is make sure all our units are canceling when we set up equations like this. So we start off with 1 quart per 2 miles, and then later on 1 mile per kilometers. So we end up now with mile divided by mile. They will cancel off. We have 26 kilometers. We also have the mile per kilometer. So we end up with a kilometer divided by kilometer. It cancels off. We have quarts, we have bottles and milliliters. So we don't have anything canceled off yet. So now we have to convert between our quarts and our milliliters. When we put that in, we'll end up with 946 milliliters per 1 quart. This will allow that first quart in the beginning to cancel off with the last quart at the end. Our 946 milliliters divided by 500 milliliters will cancel off. We're left with bottles. Now we run this all through our calculators, and if you're really doing the hike, you at the very end you round up to figure out the number of bottles that you have to carry. So if we're traveling at 90 kilometers per hour, if we don't look for a second, how many distance have we traveled in that 1 second? So we have rate and time. So 90 kilometers per hour times 1 second. But our units aren't matching, so we have to make the hours and seconds match. So we find the relationship. 1 hour is 3,600 seconds. If you don't know that, 1 hour is 60 minutes. 1 minute is 60 seconds. This will cancel off our hours. It will also cancel off our seconds. We're left with kilometers. Well, we're asking for meters. So now we need the conversion between meters and kilometers. That's 1,000 meters is 1 kilometer. Now our kilometers will cancel. We're left with meters as our answer. So we've traveled 25 meters in that 1 second. Another one, if we have an acre foot of water, that means we have 1 acre, which is 43,560 square feet. 1 acre, a foot deep with water. That's an acre foot. How many liters is that? There's a couple different ways that we can plan to go from cubic meters for acre foot. So acre foot is 43,560 cubic meters. We can go and look up a conversion factor directly between cubic feet and liters. If not, we'd use what we know. So we know there's 12 inches in a foot. We know there's 2.54 centimeters in an inch. We know there's 1 decimeter in 10 centimeters, and that there's 1 liter in 1 cubic decimeter. So we go through and check the units. Now on this we have cubic feet. Well, we have 12 inches in 1 foot, but we have cubic feet. So we have to cube that whole conversion there. So it would be 12 inches cubed over 1 foot cubed. So we have to watch the exponents on this also. And after we do this, we find out there's 1.23 times 10 to the 6 liters. So 1.23 million liters in 1 acre foot. These are the formulas from the chapter, formulas that we need to know, which also means that we are at the end of the chapter. We have one value, which is only the density of water, which is 1.00 gram per milliliter.